Welcome to DuckTech School of Maths. If you are new here, please subscribe to our YouTube channel. Right, today I want to talk about linear simultaneous equations. Simultaneous equations are just a system of at least two equations with at least two unknowns. So we'll be solving for several unknowns using several equations. So in this case, I just want to talk about two unknowns in two equations using the elimination method. I'll be using the elimination method. I've already posted something on the substitution method, another way of solving simultaneous equations. Right, so we have a few steps that we have to follow. So the first step is to choose one unknown to be eliminated and make sure that the coefficients of the unknown to be eliminated in both equations are equal. For example, if we decided to eliminate x, we have to make sure that the coefficient of x in the first equation is exactly the same as the coefficient of x in the second equation. Right. Then the next step, we are now looking at the signs. If the signs are the same, plus and plus or minus and minus, then we subtract one equation from the other. Otherwise, we add. I'm saying if it is plus and minus, we just add the two equations. By so doing, we'll be eliminating the desired unknown, right? Then in step 3, we are now solving the new simple linear equation that we have formulated in step 2 above, right? And obviously the fourth step is now to find the corresponding value of the unknown. After solving for one unknown, we now want to find the value of the second unknown. So we substitute the value of the unknown that we get in step 3 into any of the two original equations and find the corresponding value of the other unknown. I encourage you to use the original equations so that you won't use the wrongly formulated new equation. Right, so let's move on to our first example. In this case, if you look at the first two terms in both equations, we have 2x plus 3y is equals to 5. 2x minus y is equals to 1. If you look at these two, we have 2x and 2x, right? So it is very easy to eliminate x. We want to eliminate x. So since the coefficients and the signs are the same, what we are going to do is we are only going to subtract the equations. So the choice is yours. It's either equation 1 minus equation 2 or equation 2 minus equation 1, but you have to maintain the order, right? I want to subtract equation 2 from 1, so this x minus this x, I get 0, right? Then 3y minus y, I will get something like this, is equal to 5 minus 1, since I am subtracting equation 2 from equation 1, right? Then I am now solving this new simple linear equation, right? So 3y minus y is 4y, and 5 minus 1 is 4. Right, now dividing both sides by the coefficient of y. The coefficient of y is 4. So dividing both sides by 4, we find out that this 4 cancel with this 4. This 4 in this 1 into this 4 is 1. So we find out that y is equal to 1. Now, having this value of y, we can now use this value of y to find the corresponding value of x. Now, let's substitute this value of y into any of the equations, either equation 1 or equation 2. Right, let's substitute this in equation 2, where we are saying 2x minus y. Instead of writing y, we are no longer writing y because y is 1. We are now writing 1 for y. Right, Now solving this equation, we are taking we are taking minus 1 to the other side. We are taking minus 1 to the other side, and it will be plus 1. So it will be 1 plus 1. So 2x is equals to 2. Dividing both sides by 2, we find out that x is equals to 1 as well. Right, let's move on to our second example, since we have solved for both y and x. So we have solved the simultaneous equations. Right, let's move on to our second example. Right, in this case, if you look at the coefficients of a in the first equation and second equation, they are totally different. The same as the coefficients of b in the first and second equations, the coefficients are different. So we have to choose one unknown that we want to eliminate and make sure that the coefficient is the same. The coefficients are the same, right? So let's eliminate b. So we want to make sure that the coefficient of b in the first equation is equal to the coefficient of b in the second equation. We do so by finding the lowest common multiple of the coefficients. In this case, we have 2 and 3 as the coefficients of b. So the lowest common multiple is 6. So for this one to be 6, for this 2b to be 6b, we have to multiply the entire equation by 3. So we are going to multiply the entire equation by 3. At the same time, for the second equation, for this b, for the coefficient of b in the second equation to be 6 as well, we also have to multiply the entire equation by 2. Right, in such a way that if we multiply 3 by 3a, we get 9a. 3 by 2b, we get 6b. 3 by 10, we get 30. And we now have this equation. Right, let's also multiply the entire equation. The entire equation here, let's also multiply it by 2. So 2 by 2a, get 4a. 2 by 3a, we get 6. By 3b, we get 6b, like this. And 2 by 5, we get 10. Right, now that the coefficient of b in the first equation is now equal to the coefficient of b in the other equation, we can now move on to the signs. Let's check the signs of the terms to be eliminated. And these are the signs of the terms to be eliminated. They are both positive, which means they are equal. Since they are equal, we are going to subtract. So the choice is yours. It's either equation 1 minus equation 2. I want to subtract equation 2 from 1, right? So 9a minus 4a, get 5a. Then 6b minus 6b, 0. I have eliminated b, right? 30 minus 10, we get 20, like this. Then solving for a, we are now dividing both sides by 5, and we find out that a is equals to 4. Now having the value of a, we can now use this value to find the corresponding value of b by substituting 4 for a into any of the original equations. Right, so let's substitute this into the second equation. The second equation is 2a. So instead of a, we are no longer writing a, we are now writing 4. We are now writing 4 instead of a. So it's now 2 by 4 plus 3b, which is equals to 5. Right, simplifying this one and solving for b, taking this one, this is 8, taking it to the other side to find out that 3b is equal to minus 3. Dividing both sides by 3, we get the value of b being minus 1, like this. Right, in this case, if we look at the coefficients of h, they are totally different. The coefficients of k, they are totally different as well. So let's choose. In this case, it is very easy to make this k being equal to 3k, right? So we are going to multiply the entire equation here, the whole of this equation 2, we are going to multiply it by 3, like this. We are going to rewrite equation 1 as it is, because the coefficient of k there is already 3, so we are going to rewrite it as it is. Then we are now multiplying equation 2 by 3. So 3 by 3h, 9h, 3 by k, 3k, 3 by 18, 54. Right. Now that the coefficients are the same, we now have 3k and 3k. Now we are now concentrating on the signs. These are the signs of the terms to be eliminated, and they are different. And I said if the signs are different, we simply subtract the two, we simply add the two equations, we add the two equations. So it is equation 1 plus equation 2. So 2h plus 9h is 11h, 54 plus 1 is 55. Dividing both sides by 11, we find out that h is equal to 5. Substituting 5 into n of the equation to find the corresponding value of k. Right, let's substitute into the second equation, where we are saying 5 by 3 plus k is equals to 18. This simplifies to 15. So taking 15 to the other side, it will be 18 minus 15. So k is equal to 3, like this. Right. Now, here is your exercise. You can practice with these questions, and you can pause for the video for a moment, then resume for the answers. And here are the answers. Thank you very much for watching. Please don't forget to subscribe, like, and share our videos.